Again, thank you all for taking time out of your valuable schedule and joining this call. Today, we are going to talk about container adoption and why we think that Kubernetes is solving half the problem for enterprises that are looking to adopt containers within their infrastructure. It's a very hot topic. There is a lot of discussions and activity that is going on today with respect to containers and Kubernetes. So we will present our point of view, and we hope to make this discussion very informative and make it very useful to all of you guys. So once again, thanks for joining the call, and let's get started. Just a quick introduction about the two speakers today. My name is Mayur Shah. I'm the Director of Platform Marketing here at WaveMaker. I've been in the industry for almost 2 decades now, and have been mostly spend my time working with enterprise software platforms. I have been involved mostly in web and cloud development, and my passions lie in tech marketing and blogging. So you can see my blogs at various channels, including DZone. With me, I also have Anup. Anup is our Director of Product Engineering for the WaveMaker platform, cloud platform. And Anup comes with a lot of rich experience in DevOps and cloud practices. Before WaveMaker, he had an entrepreneurial stint in running cloud services and application development. So thanks, Anup, for having here. If you just can say hi to our attendees.
Yeah, hi everyone. Thank you for joining.
Hey, thanks, Anup. So before we get started, a few logistics about the webinar itself. The webinar is recorded, and the slides as well as the webinar recording will be available on the website on the same page where you registered. We will send you the link of the webinar recording after the call in case you want to send it to your colleagues. If there are people who have missed out, they can view the recording at their leisure. During the webinar, we would like to have the webinar as interactive as possible. So if you have questions, if you have queries for us, please feel free to use the chat window in the webinar, and we will take time out during the end of the webinar to go through the questions. If there are questions that we cannot get to, then we will follow them up through email, and you can always reach us back later on for additional demos or additional queries as required. Also, I have a lot of APAC customers as well. So we also have with us Rahul Gupta on the call. So Rahul is our head of sales for APAC. So if for APAC customers, if you have questions, you can always go and reach out to rahul.gupta@wavemaker.com. So let's get started. I'd like to just touch upon the agenda today. We are going to talk about container adoption within enterprises. We're seeing a lot of movement of customer workloads from the VM world to the container world. And specifically, we are going to talk about what does it take to have a successful container adoption within an enterprise? What are the elements, and how does an enterprise go about putting together a process and a solution for containerized application delivery? The initial part of the webinar, I will be talking most of it, where I'll focus on the drivers behind the container adoption, and specifically what about container adoption makes it successful within an enterprise. And then later on, Anup will go deep dive into the solutioning and the technical aspects of how does an enterprise repurpose their DevOps to sort of like look at a modern approach of containerized application delivery. What are the solution aspects around it, and what are the key things to look for specifically when you're setting up your containerized application delivery. And then finally, we'll have a demo of WaveMaker HyScale, which is a modern DevOps automation platform for continuous delivery, specifically for containers. So with that, let's get started. Let's talk a little bit about what are the successful elements for container adoption within enterprise. So if you take a step back, let's set some context here, right? So what we are seeing is, recently Forrester did a survey of top 195 IT managers and executives, and kind of to see what are the trends in terms of container adoption within the enterprise. And what they found out was containers are breaking out of, initially they were used a lot for test and dev environments, and they are breaking out of that and moving to more of a production environment situation. Interestingly, what they saw is that in their survey, 63% of enterprises using containers are looking at deploying 100 or more applications for using containers. And that's a pretty big number. And in terms of the trend, the next 2 years, they see a rise of that to go to 80%, where 80% of the enterprises will have 100 or more applications using containers. And some of that has to do with the benefits that containers bring in, and we'll talk a lot about that during this webinar. But also it has to do with the way the application architectures are evolving. A lot of applications that are monolithic or legacy applications are now being transformed to microservices. As you can see here, about half of the survey respondents said that they are already using microservices. So microservices and containers sort of go hand in hand. As we see in future slides, they kind of benefit in terms of the way the applications have to scale for meeting the business needs. Additionally, we are also seeing Kubernetes. For those who are new to Kubernetes, Kubernetes is a container hosting platform where you can deploy applications as containers, and Kubernetes helps you to scale and orchestrate your container environments. So Kubernetes was a technology that was started by Google many years back, open sourced by Google a few years back, and now what we are seeing is it has become sort of the de facto standard between both the on-premise platforms as well as a lot of cloud platforms. Public cloud platforms has embraced it, and especially in the last 2 years, there's a exponential rise of Kubernetes adoption, both within the cloud platforms as well as within enterprises. And as that is happening, we are seeing that virtual machines are being kind of being replaced by containers, and that trend is what you see here. So if you take a look at why is the adoption of containers and Kubernetes happening at such a rapid pace, it really has to do with the business objectives, right? A lot of enterprises today have similar goals and similar objectives, and they are specifically to do with the ability to take their services and products faster to market so that their end users and customers can benefit from that, and do it in a much more scalable and seamless manner, right? Those business objectives, what we see is that containers and Kubernetes, which are sort of the fundamental technology required in the modern DevOps, are essential ingredients or essential technology enablers to meet those business objectives. And the reason being that containers are a very lightweight OS operating system virtualization method that not only just simplifies deployment, but also requires very fewer resources as compared to VMs. And Kubernetes is a distributed container runtime platform that helps you to scale and orchestrate your workloads. So together with these two technologies, they are helping to meet the business objectives. So now let's take a look at the enterprise and take a step back and understand what are the elements of a successful adoption of containers. So if you take a step back, there are essentially three aspects to it, right? There are your applications today, and those applications need to be delivered as containers into a container runtime platform that you see on the right-hand side. And as I mentioned, Kubernetes has become sort of the de facto standard across all those environments that you see on the right-hand side, including the public cloud platforms. And if you look at the applications today, they could be your monolithic applications, it could be your horizontally scalable, cloud-optimized applications, or cloud-native microservices applications. For all of these applications, there is now a requirement to deliver these applications seamlessly as containers into the container runtime hosting platforms. And fundamentally, what we see is that using containers to be able to deliver these applications is fundamentally different. And we'll talk a lot about that today, because in our point of view, you as enterprises are looking to embrace containerization, they really need to understand the ability to move seamlessly your applications to a container runtime platform. And that's where the application delivery needs to be relooked at and redesigned to meet the container requirements. So let's talk more about that. So let's talk about why does an application delivery change, or what about the application delivery needs to change for containers. So if you take a step back, let's look at the business drivers first, right? And this was a very interesting survey done in 2017. In fact, there's one survey that's about to come out in the next month by DevOps report from Puppet and the DevOps Research and Assessment Group. And they surveyed about 3,200 users. And they looked at, how does better DevOps practices can lead to higher IT and organizational performance. And if you look at that, high performance teams are significantly better than their lower performing peers in terms of throughput and stability. And when we talk about throughput, it's really about the ability to deploy faster, right? The deployment frequency, especially sort of an on-demand frequency, and the ability to have lower lead times for changes. And that's the throughput. And from a stability standpoint, the ability to recover fast from any errors and the change failure rates. So significantly, they are much higher in speed when it comes to throughput, and much better in terms of stability. And these are sort of aspirational goals that every enterprise has today in terms of releasing their products and services faster and better to their customers. In terms of technology as well, what we are seeing is containers themselves are much different and unlike from their counterparts VM from the previous generation, right? Containers are created much more often. As we look at microservice applications, look at more distributed applications, you have more containers that are created. They are replaced frequently because of the speed of deployment. One of the things about containers are they are immutable. Immutable as in the container images, once they are created, they are deployed, they are never updated or modified. New versions of the application require replacement of the existing containers. So they are immutable in that respect. And finally, the container technology is all pre-built. So before you deploy your application, you pre-built all your images and deploy them to the container runtime environment. So these are evolving technology practices that are very specific to the container world as opposed to the VM world. And finally, if you look at the enterprise itself, the roles and the responsibilities are changing as compared to virtual machines, right? So if you look at the life cycle of deploying your application and setting up your environment, all the way from provisioning, installation, configuration, deployment, and upgrades, throughout the life cycle, in the VM world, you used to have multiple roles, and the responsibilities were sometimes not very clear. And that really kind of caused some friction to standardize on some of the practices. There were a lot of manual efforts and scripts that were required to get your environments up and running, as opposed to a container world where you have a lot more demarcation with respect to the roles and responsibilities. And with that, you can see clearly here that it's a much more frictionless sort of an environment where you can standardize things and you can make things move much more faster. And so with that change in responsibility and the change in process, there is that enterprises have to look at this and see how it fits into their process and their teams. And it's much more efficient and much more resilient to move this to this type of a setup. So we talked about the changes in the container app delivery and what are the elements. Now let's now specifically deep dive into what would it take to what is containerized application delivery and how do we look at that. So with that, I would like now to move to Anup. Anup will take us through the details of the containerized application delivery. Over to you, Anup.
Yeah. Thanks, Mayur. Hello, everyone. My name is Anup Balakuntalam. For those of you who missed the initial introductions, I run engineering for WaveMaker HyScale, which is a modern container-based application delivery platform. And I'm also responsible for the overall architecture for an online PaaS, which currently supports thousands of containers in production. So as you can imagine, we've been burned a few times, and you know, those learnings and experiences are what we hope to share with you today. So getting back to where Mayur left off, let's look at what containerized application delivery is all about. And as Mayur mentioned, it's totally different from the way we would do application delivery in the case of VMs. There are various drivers for why it's different. There are business drivers, there's technology change, and all of those things. So if you look across the life cycle for application delivery, and these pieces that Mayur also talked about, installing, configuring, provisioning, and then fixing things. Across all of these, there are a set of new things that we need to take care of in order to containerize the whole delivery. So to go into this a little bit, and I'll talk more on this through the rest of the presentation, but you would want to have some sort of an enterprise catalog of images. You need all of your base images, which are certified for use by different application teams, which are, you know, possibly hardened, fine-tuned, and stuff like that. You would need to have Docker file generators. So you need to think about how are you going to have, how are you going to write and maintain Docker files for all your various applications. So are you going to hand code them, or do you need generators for that, so that you can handle changes? And then you would need some sort of image building mechanism, because you're going to build lots and lots of images, especially with the advent of microservices and the growing number of containers. You're going to be delivering probably hundreds of containers every day onto different environments. So these could be dev, test, etc. And then, you know, how are you going to configure them for different environments? How are you going to deal with configuration profiles across dev stage, production? How are you going to resolve dependencies across these different containers and stuff? We'll talk about pods in some time. How are you going to generate the artifacts, specifically the cube specs, the YAML files, and so on, in order to deliver all of this to Kubernetes? So there's as you can see, there's a lot of stuff that we need to deal with. So one of the things that may come to mind is, you know, we have all these VM tools and scripts, and why don't I just try to repurpose whatever I have? So as we saw, there's a fundamental difference between the way VMs work and the way containers work and the way we do delivery. So in the VM world, you know, we might be dealing with tens of deliveries a day, delivering applications to VMs. But then you move to a microservices world, a container-based world, and then suddenly we're dealing with, you know, hundreds, if not thousands, of container deliveries a day. So, you know, just trying to work with VM tools, adjusting them, tweaking them, introducing manual steps and scripts is not really a scalable idea, and for good reasons that we will see further on in the upcoming slides as well. Another aspect is that you cannot have silos anymore because there are dependencies between ops and dev, and this is something that we as an industry have been working towards for a very long time. How do we get the whole DevOps culture going and all of that? But I think it gets even more important in the context of containers than it was in the context of VMs. So that's another thing. And then, as Mayur mentioned, container images are immutable. As a best practice, you don't go in and change your containers, the running containers. Anytime you need fixes, you're going to rebuild container images with the fixes. And so unless you have some standardization around it, it's really hard to deal with it at scale. So how do we achieve containerized delivery in order to complete the adoption to Kubernetes, right? So in order to understand that, let's look at the VM-driven DevOps, and then we'll contrast this a little bit with container-driven DevOps as well. So in the VM world, so you have your sources, you have Jenkins, Bamboo, whatever equivalent of that to build your application binary. All of this is DevOps. And in order to deploy these application binaries, you would require VMs to be provisioned, and that's typically IT that you can see in green here. And then on these VMs, you would need to install the stack that is required for the application to run. In the case of some organizations, that's done by IT. They would probably give you VM images with the stack in it, or in some organizations we've seen this could be done by DevOps, where the stack is installed using scripts or recipes and so on. Then you would need to configure your VM. So typically IT is configuring the VMs for a bunch of different reasons. So they're configuring for security, for hardening, and so on. And then you have DevOps who's also configuring the same VMs for making it ready for the application to run. And then finally, once this application is there, you have both of these teams looking at the VMs. And when things go wrong, you might need to involve IT, you might need to involve DevOps, and typically all of them are looking at it and might do some reconfiguration at some point. So as you can see, there's a lot of mix and match of the responsibilities over here, and that is something that we typically tend to describe as friction. So let's now look at the container-driven DevOps workflow. So the first few steps are still required. You still have your sources, you still need to build those, you still need to generate your application binary. But now, after that, things are a little bit different. So you need to then build an image with these application binaries on top of the stack that you require. And so what IT does in this scenario is now cleanly separated onto the right-hand side, the green box that you see here. So IT will typically publish a set of base images with the stack for use by various application teams, various DevOps teams across applications. And then these teams, the DevOps teams, will then utilize those base images, take the WAR files, put them on top of those base images, and then build your application images. And then, along with those application images, they will also have to supply the configuration and then generate or write deployment specs in order to provision all of this or deploy all of this onto a Kubernetes environment. And all that IT would do is set up this whole Kubernetes environment and make it available for the teams to provision their containers onto. And then, as Mayur mentioned earlier, anytime you need fixes, you would need to go back and rebuild images and essentially go through this whole cycle all over again. So when we look at this picture, there are a couple of advantages that we can identify in this new workflow. So one of them being that there's clean handoff between DevOps and IT. You have standardization of certain stacks and images across your enterprise. And then finally, with all the reduced friction, you're able to now do much faster application delivery, which is the primary reason that we got into all of this, right? So those are the key advantages that we see with the container-driven DevOps. So how do we achieve this whole container-driven DevOps in order to complete the adoption of Kubernetes, right? So there are 4 pieces of the solution that we'll focus on. And the first thing that you would require is a clean handoff between development and operations so that dev and ops can work truly as one. And so you will need to have some way for the application teams to define services, to define the dependencies, the requirements, the configurations for those services to run in some sort of a simple way, and this could be JSON, YAML, whatever formats, but then have some sort of a services framework which can then resolve all of those things, so that you get a clean handoff here, right? And the second piece that you would need to have is an enterprise level catalog of all the different packages. It could be Java, JBoss, Tomcat, MySQL, whatever you have it. So that you can have hardened, well-tuned base images, container images available to the rest of the development teams, to all the application teams in the enterprise. And then obviously you will need some sort of a repository that can hold these images in some way to categorize and tag all of this. The third piece of the solution is you will need to have image builders or some sort of an automated mechanism so that you can build lots and lots of images. You can have versioning onto them so that you can go back and see what changed in different versions, when did those changes happen, and so on. And then there's the final piece of the solution is you need to have some way to have configurations for different environments across dev stage production, and then can you really go back and look at what is the difference in configuration between these environments, how these different configurations are then delivered onto a Kubernetes platform. And this whole configuration thing is something that that has tripped up a lot of us. You have some differences in configuration between environments because of which it doesn't work, and so on. So you need to have a robust configuration system with change tracking. And finally, you need some way to automatically generate your kube specs, your deployment artifacts, so that you can have a seamless delivery. So those are the 4 key pieces which will help us complete the application delivery in order to complete the Kubernetes adoption. So if we take a step back now and look at what are the characteristics to look for in a modern container delivery mechanism. So these are some things that a good container delivery platform would have or would offer you, right? So first of all, you have standardization for your stacks, and this helps you to have a common set of base images across your organization. This will help you to do delivery faster and to be more secure. And it also promotes reuse. So that's important. The other thing you want to be able to do is provide self-service to all of your application teams so that they can go in and simply specify what their service requires, and then have the rest of the delivery handled by the platform. And it goes without saying that we need automation to generate Docker files, automation to build Docker images, automation to generate kubespec, YAML files, all of that stuff, and that would be great to have, right? You want to have as little disruption as possible. Many of us have a lot of infrastructure for building applications. We might have Jenkins, Maven, all of those things, or Bamboo or whatever other stuff. And then we also have a lot of test infrastructure, Selenium, JMeter, etc. And we want to be able to utilize as much of that as possible. You don't want to rip off everything and then redo it in a different way, because that would take a lot of time. And then you want to have a way to push to multiple clouds. So you might have Kubernetes environments set up in different clouds. And I think the auto push is really important because it really brings down the amount of learning that needs to be done by the teams in order to really leverage Kubernetes. And we'll see why that is the case as I get into the demo in a short while. And finally, automation as a black box isn't really helpful, especially when you end up with issues and you need to debug. And so you need to have some way to look at things, at what is changing, when and why, and to have some transparency around the whole process. So these are the key things to look for. And so with that, I would like to give you a glimpse of what a container delivery platform might look like. So first of all, you would already have a bunch of inventory in your enterprise. So you might have some operating systems that you support, so you need some base images with those operating systems. You might have packages around JBoss, Postgres, etc., etc. So that's something you want to reuse or leverage. You might have artifact repositories, JFrog or other such things. You may or may not have Docker repositories already in your enterprise, but you will definitely need one. And you already work with certain hosting providers and have certain instances and clusters, and you want to see how much of this you can leverage. Then you need to be able to go into the platform and define or declare what your application looks like. So your application consists of several services. These could be a few or many, depending on the architecture of your application. And then each service has a definition. What sort of stack dependencies does it have? What other services does it depend upon? What kind of configuration property does it require, and so on. So you need to be able to declare all of this. Then you need to be able to quickly generate different environments that you may need, dev stage, production, test, whatever else, right? And ideally, you want to be able to do this within minutes. And then you also want to be able to clearly define and look at the configuration profiles for each of these different environments, the configuration properties for all of your services across these environments. So once you've defined all of this, then you want to be able to kick off some sort of automation that then takes all of this inventory here into consideration, and then takes all of these definitions and declarations here, and then builds the necessary images or the necessary image layers, generates those Docker images, generates the required cube spec payloads, and then delivers that payload onto your Kubernetes hosting environment. And then remember that you would be doing this multiple times a day for any given service, because you're pushing this to different dev test environments, staging environments, whatever. And then you're also going to be doing this multiple times for multiple different services that you have across your organization. So it could quite easily amount to several hundreds of image builds and image deliveries, service deliveries onto Kubernetes in a given day. And so this piece is something that you would like to have as automated as possible based on some sort of declarations of these things. So with that, I would like to now give you a brief demo of WaveMaker HyScale, which is a modern platform for automated container delivery. So we've been early adopters of Docker at WaveMaker since 2013 for our various needs. We built an application delivery model on containers even before Kubernetes. We had our own container orchestration, and we've been running in production for the last 5 years, supporting thousands of containers there. We've engaged with several large enterprises in the process, and now in recent times we've adopted the Kubernetes approach, and that is what we bring into WaveMaker HyScale as a platform.
What you're seeing here is the HyScale dashboard for the applications, and you can have multiple applications here, each having multiple services, different environments running. So I'm going to click into one of these applications. So this is an employee details app where you maintain details of different employees. It's a very simple application that we've chosen for the sake of this demo so that it's not very crowded. You will see when I switch into the Kubernetes screen to show you the generated artifacts, there's a lot of different artifacts even for a single service. So this is where you would define your services. So I have a service which I've named simply as web, another service which I've named as MySQL. If I look at the web service, I have declared at the time of adding this service definition in, I have declared that this service depends upon Java 1.8, Tomcat 8.5. So a lot of these things are simply declarative. Once you declare this, then this service image will be built out of these base images. And there's a repository where you can maintain these base images. You can generate and define what these different base images are, and then all your applications and different teams can then utilize these kind of base images, which could be anything. It doesn't necessarily have to be Java or Tomcat. It could be Ruby on Rails. It could be JBoss and so on. So you define your service. You say what is the stack required for this service to run. Where do I get the artifacts for this service? In the case of Java, these could be WAR files, jar files, and so on. So we currently support JFrog Artifactory to go pull the artifacts from, or it could just simply pull it from a Jenkins machine, or just an SSH location, an SCP location. And then what are the configuration properties required for this service to run? So there's a bunch of stuff here which is from the stack. There's a bunch of stuff required for the application to run, and so all of these things form a part of service definition, which typically a DevOps team or a development team would know and would simply come in and specify. Once you've done that, then it's fairly simple to run an environment for this application. So we have some environments running here, but what I'm going to do is I'm going to create a new environment quickly, and then we can see how this works. So let's so there's a few details here. There's a name, there's a registry where the images will get pushed. So we've defined a Kubernetes cluster in the infrastructure section. We can have one or more Kubernetes clusters, each running in different clouds, something in your local data center, something could be running on AWS or Azure and so on. So you could have different clusters. You get to pick the cluster on which you want to create this environment. And then once you pick the cluster, it will go query the cluster for the namespaces that already exist within that cluster. So you could simply pick one, or you can even create a new namespace from here. So I'm just going to pick this namespace here. And these are the services of your application. These are the different revisions of the services. Every time you change the service definition, a new revision gets generated. So you can go in and look at the revisions in the service definition section if you wanted. You pick the services, then you come into the configuration. So you pick how many replicas, how many pods you want to run for each of these. You can pick a size, and then you can set up all the configuration properties that you saw. So you saw some configuration properties being declared as part of the service definition, and you can now pick the values that you want for this particular environment, which is the demo environment that I'm launching. So I'm going to go and provision that. This is the first deployment, so I'm going to I'm going to basically deploy these images. I can version these images, and then I can specify an overall release version of this entire application that I'm deploying to demo, and then I can provide some of these nodes for reference. So let's click deploy. So right now the deployment is in progress. At any point in time, I can click on this and I can see, okay, it's building some images. So there's an artifact image, and then we layer the service artifacts, the service on top of it. So you can go look at all the different layers of this image, and I'll show you that once this process is done. So you can monitor your deployment process over here. So while this should take about a minute, and you can see the image building is already done. It's pushing the images to the registry, and then it will connect to the Kubernetes cluster and push those, launch those services. All right. So we'll give this a minute. In the meantime, as you can see, we have already deployed to dev. We have a dev environment, a stage environment, a prod environment that we had already pre-created here. One of the cool things you can do is to go look at, how does my stage differ from my prod, and I can just go pick that, and it will give you a difference between your stage and prod. So you can clearly see it has highlighted some of the differences. So there's a difference in the number of threads and so on and so forth. So it's fairly simple to get some visibility across your environments. And as we said earlier, this is a thing that has tripped us many times, and it's important to have this. Another thing I want to quickly go back and show you is how you can have a repository of different packages. So you can have, this is the repository that is published to and established by IT. You have hardened images for MySQL. You can have Java, Tomcat, Node, and you can have one package derived from another. So your Tomcat image might depend upon your Java and so on. And finally, you get like an image catalog that you can search through. You can filter through that, look at what is available. So you have Redis, you have various things. And then you can see what these images actually consist of, right? So The Docker files are automatically generated for you. The Docker images are automatically built for you, so you can look at the build logs and so on. And one of the key things is everything that you see here in this UI, you can actually achieve through the CLI or through APIs. This is just a very quick run through that I'm providing. So it looks like the demo got deployed. Let's go and see what exactly happened. So I got this going, and I have some pods. I got the pod IDs. I can look at their status. But I should be able to just click in and then launch the application. So very simple, basic application here. But the interesting thing is to go into Kubernetes and see what happened. So if I log in here, and if I look at the namespace that we used, so if I look at the employee demo namespace, this is where we provision the demo environment. So you can see it has generated a bunch of things. So it has generated the deployments for you. It has generated some pods. It has generated replica sets, so I can pretty easily go in and scale it up. There's a bunch of services which are required for service discovery, and then there's some configuration. So there's a lot of stuff that has automatically been generated. Typically, you would write and maintain hundreds of lines of YAML files for all of this, especially if you have a large application with many different services. And then once you're into the Kubernetes environment, then it's fairly simple to go in here and you want to scale up a particular service and do all of those things. So that you would continue to do within your Kubernetes environment. And then there's a final thing that I want to kind of show you as a glimpse, and then we'll get into some Q&A. So you might have deployed multiple times to a given environment and different versions, right? And then you want to be able to see what was the change between two versions that were deployed to this environment. And you can just go in, look at the change tracking section, and then you will get all the differences. So you can see here 1.0 was pulled from a Jenkins instance, the WAR files and artifacts, and then if you look at 1.42, it was switched to JFrog at some point between the two versions. You have some differences in the build number, some different properties, you know, some different commands and configuration. So you can really go and look at what was the difference between two versions, any two versions that were deployed to any given environment. And then one thing with these differences is we said that you can go in and look at your image, and these are the different layers of your image. So you have your stack for any image that gets built. So this is the stack layer. You have your artifacts, which is layered on top of it, and then you have your configuration. So any images that get automatically generated by HyScale is always built in layers. So we cache these layers for faster image generation. And if only the properties has changed from one version to another version, then we only build the service layer so that you're assured that the artifact and stack portions are exactly the same, because it's reusing those images. And so depending on what has changed, only that layer is what gets generated again. So this not only gives you speed, but it also ensures that the same artifact is going in again, but with different configuration. So that's how different versions are generated, how different versions are tracked. So this is just a very brief demo to show you several of the things that we talked about as a solution to modern containerized delivery. If you like what you see, we can always set up some time one-on-one to go through in more detail how this can be leveraged for your organization.
Hey, thanks, Anup, for that detailed demo. Really appreciate that. So now we will move to the last part of the segment of the webinar, where we will open up the mic for Q&A. At this point, if there are questions, if there are inquiries, then you can use the chat window to put your questions, and we will be more than happy to answer them. We have received a few of them, so I'll go them one after the other. And in the meantime, if we get additional ones, we will take them and answer them. So one of the questions I have here is, during the presentation, you guys talked about disruption when an enterprise moves from a VM-based setup to a container-based delivery setup. So can you elaborate on the kind of disruption should an enterprise expect and how to mitigate the risk associated with that disruption? Anup, do you want to take that?
Yeah, sure. So essentially, there is a change in the tooling aspect and the automation that is required. So you definitely need some new tools that might bring in some initial disruption. At the same time, you want to be able to leverage as much of your existing tools with regard to the way you build your applications, the way you test your applications, and so on and so forth. And then also, once you've adopted this whole new tooling, you want to ensure that the disruption on an ongoing basis, on a day-to-day basis, is minimal. So that's a very key aspect.
Okay, great. There's another question I have, which is, from your experience working with customers, what kind of gains do you see from moving from a VM to a container-based delivery model? So I can take that one, Anup. So we work with a number of industries and customers, and one of our customers, to give you an example, has an omni-channel retail product, and they were basically using the VM-based approach to deploy release their application environment to both on-premise environment where some of their customers were on-premise, and also they had a cloud-based setup, both on Amazon as well as a private cloud setup to deploy their application so that other customers could use that as well. And so earlier, what would happen is, their DevOps team would huddle on weekends, spend like almost the entire weekend every time they had a release of the product or the application, and it really took almost them a couple of days to get the configuration, scripts, environment, and then the provisioning and setup done, right? So when they looked at containers and they were sort of dabbling the idea of moving to container-based application delivery, they looked at HyScale and with the platform automation approach for container-based application delivery, they were able to move from a couple of days to a couple of hours in terms of the time their binaries were all ready to be deployed. They would take a couple of more hours to deploy the application to various environments. And interestingly, also, they had about 150 or so VMs or machine instances across both on-prem and cloud when they were initially using VM-based setup. And they were able to reduce that to a couple, 20 or 30 VMs in which all their containers would be running. So significant gain in terms of reduction in time, both in terms of deployment and reduction in the cost when it meant for supporting all their environments for their application. So those are the kind of benefits one can expect. It will vary based on application environments and setups, but this is what you can expect. There's another question I have, which is, what role do you guys think continuous delivery platform should play in accordance with Kubernetes? So do you see a role that each of them play individually, and where does the integration lie? Do you want to take that, Anup?
Yeah, so I'm not sure that I fully grasp the question here, but essentially the goal of continuous delivery, irrespective of whether it is VM or it is containers or Kubernetes or whatever, is that we're able to deliver fast. It's frictionless, so that you can do a delivery at any time on demand, and it should happen quickly and in a very predictable, reliable way. I think that's the broad goal, which remains. I think that's been the case for many years. But in terms of the way continuous delivery would happen, obviously there's a difference in the Kubernetes world, simply because you now have to pre-bake or generate everything, right? So your entire application, the stack required, the dependencies, the configuration, all of that is pre-baked and then pushed onto the Kubernetes environment. So there's a fundamental difference in the way we look at continuous delivery itself and how we can achieve it.
Okay, so with that, I think we are almost towards the end of the webinar. I again thank all of the attendees to spend their valuable time in sitting through this webinar. Hopefully this was very informative, and at any point, please feel free to go to our website, wavemaker.com, get started, and you will see a lot more information about containers, a lot of blogs that we write on a continuous basis about how we think enterprises should move to container-based application delivery. And at any point, if you want to see a demo or have more inquiry about WaveMaker HyScale platform, then please feel free to send us an email or go to Get Started and send us an inquiry, and we'll be more than happy to set up a call. So once again, thanks so much for joining the call. All of you have a great day, and for the folks in India and APAC, have a great night. Thanks, bye.
Thank you, everyone. Good day. Bye.